Okay, this is not the ideal circumstances. This is not terribly well prepared. I apologize for everything, but I'm going to do my best. I want to do a quick video today on what I call the nice angles. Like so many other things, this is a term that other people don't use. I do. What am I talking about? There's two places in trigonometry where we can just use simple geometry, the Pythagorean theorem, to find out trigonometric values. And the two special triangles, oh, and there's a train going in the background. My email's going to be pinging, whatever. The two special triangles are the isosceles. The isosceles triangle has two congruent sides, and then the equilateral triangle. Terrible handwriting. Equilateral triangle with three congruent sides. Now, hopefully you know that this one is a 45, 45, 90 triangle because if these two sides are the same, then these two angles are the same, and the three angles have to add up to 180 degrees. This one's 90. The other two have to be equal, add up to 90. They're both 45. These three angles are all the same, so they're all 60-degree angles. Now, the cool thing is now we can make them bigger or smaller. I want them so that their hypotenuses are, well, so the hypotenuse of the isosceles triangle and all three sides of the equilateral are 1. Now over here, we know that, well, let's see. If this angle side is x, this side is also x, we can use the Pythagorean theorem to say that x squared plus x squared equals 1, 2x squared equals 1, x squared equals 1/2. There's so many ways to write this. We could call it, well, it's not plus or minus, although in later trigonometry it will be plus or minus. The square root of 1/2, that's the square root of 1 over the square root of 2, which is 1 over square root of 2. Some people are taught that you rationalize the denominator, you multiply top and bottom by the same thing so it doesn't change. The fancy version of 1 being root 2 over root 2, and this turns out to be root 2 over 2. For some reason, that's the one I always learned when I learned trigonometry, but any of these other ones are equivalent. So we get this triangle where it's a 1, so the hypotenuse is 1, and then the adjacent side is, to this angle specifically, is root 2 over 2, and the opposite side is root 2 over 2. And this gives us lovely things like the sine of 45 degrees is root 2 over 2. Well, opposite over hypotenuse, you divide that by 1, you just get 1. The cosine of 45 degrees is also root 2 over 2, but it's this root 2 divided by this hypotenuse. And we get the tangent of 45 degrees is root 2 over 2 over root 2 over 2, which is 1, and so on. I'm not going to go through all of it. There's the notes. I'd like to keep these videos kind of short, but suffice to say, 45 degrees, also known as, what is it, 45 degrees, if you want to multiply, but turn it into radians. Pi radians is the same thing as 180 degrees. You get those degrees to go away. 180 is, 45 times 2 is 90, so this is pi over 4. So you could say that the sine of pi over 4 is root 2 over 2 to use radian measure. Now, let's just finish this off with the other nice triangle, and we will worry about this one is gone. Come over here. Now, the trick on this one is it's not a right triangle. To make it a right triangle, we chop it in half. And we chop it in half, it does several things. It turns this angle into a 30-degree angle. It makes this side 1/2. So let's rewrite that. We've got a triangle which is 1/2 this side, the hypotenuse is 1, this is 60 degrees, this is 30 degrees, and this, we don't know what this is, but this is pretty easy to figure out. 1/2 squared plus x squared equals 1 squared, that's the Pythagorean theorem. 1/4 plus x squared equals 1. Hopefully we can just subtract the 1/4 from both sides and see that x squared is 3/4. So x is the square root of 3 over 4, which is the square root of 3 over the square root of 4, or root 3 over 2. And this is a little offers us a little bit more information. We have the 60 degrees, we have the 30 degrees, 1/1/2 root 3 over 2. And the cool thing about this is that we can do all sorts of things. The sine of 60 degrees is, here's the angle, this is opposite, root 3 over 2 over 1. Root 3, and the cosine of 60 degrees is adjacent, is 1/2. But on the other hand, if we wanted to look at it specifically in terms of the 30-degree angle, then the opposite is 1/2, and the adjacent is root 3 over 2, and the hypotenuse is 1. So you get something like, I don't know, the tangent of 30 degrees is opposite 1/2 divided by root 3 over 2, which is 1/2 times 2 over root 3, or 1 over root 3, which is root 3 over 3 if you go through the whole rationalizing process. What else? I mean, are you remembering things like, I don't know, the secant of 30 degrees? Secant of 30 degrees, that's what? 1 over the cosine of 30 degrees. And the cosine of 30 degrees is adjacent over hypotenuse. This is 1 divided by root 3 over 2, so it's going to be 2 over root 3, and so on. Anyway, that's the whole lesson for today. Just to know that there are two special triangles that, because of various geometric properties, the 45-degree angle, we know it's root 2 over 2, root 2 over 2, and 1. And then this 36, which, and this angle is also 45, so it doesn't give us anything more. But the 30, 60, 90, the trick here is that the hypotenuse is 1. The shortest side is 1/2. The middle side is root 3 over 2. These are definitely worth remembering. And now I have to find some homework for it, and I'm not quite sure how I'm going to do that. But good luck.